Good morning, guys. Today we're going to be doing a lesson about parallel and perpendicular lines, more specifically the slopes of parallel and perpendicular lines. This is a really short and easy lesson, so let's just get right into it. Okay, so this is lesson 6.2. Most of you probably know what parallel and perpendicular lines are. So parallel lines are lines that never meet. Perpendicular lines are lines that meet at 90 degrees. However, more importantly, we're talking about their slopes now. So parallel lines are lines that have identical slopes. Perpendicular lines will have slopes that are negative reciprocals of one another. What that means when we say that it's a negative reciprocal, the reciprocal part means that we flip the number upside down. Negative doesn't necessarily mean we make it a negative number, it means that we change the sign. So if the first line has a slope of -2, the perpendicular line would have a slope of 1/2, because I'm going to change from a negative to a positive number, and I'm also going to take the -2, which, because it's a whole number, could be written over 1, and flip it upside down to make 1/2. For another example, if I had a slope that was a fraction, like 2/3, again, the perpendicular slope would be flipped upside down, so 3/2, and I would change the sign. So if the original slope was positive, my new slope would be negative. The one kind of difference with this is horizontal and vertical lines, which are also perpendicular, so like a horizontal line and a vertical line. The horizontal line will have a slope of 0, as we talked about yesterday. The vertical line would have a slope that is undefined, because if I take 0 and I try and make the negative reciprocal of it, so 0 is really like 0/1. If I try and do -1/0 in your calculator, that is undefined, because no number can be over 0. So that's kind of the easy part, is just like if you see two slopes that are the exact same as each other, they're parallel, and again, perpendicular, you just take the negative reciprocal. So flip the number upside down and change the sign. I'm going to now go through two examples of questions that use that information, but it's not just asking you for the slope of lines. So the first one, first example here, says that line A passes through these 2 points, line B passes through these 2 points. Figure out if the lines are parallel, perpendicular, or neither. So step one is going to be to find the slope of both of these lines. So for line A, our slope, again, we're just going to do y2 minus y1 over x2 minus x1. So this is our xy, xy. So we'll do -5 minus 1 over -5, take away -2. So -5 minus 1 is -6. -5 take away -2 is -3. And -6 divided by -3 is 2. And then for line B, we'll do the same thing. So we've got xy, xy. So we'll do -2, take away -4, and -6, take away -2. So -2, take away -4 is 2. -6, take away -2 is -4. Which we could also write as -1/2. That is the simplified version. When you have two negative signs, like we did in line A, they cancel out. When you have one negative sign, regardless of whether it's on the top or bottom, it's always good practice to just write it on top, like I've done here. And then obviously 2/4 can be simplified as 1/2. So that was step one, is just find your slopes of each line. And then step two is just to compare your slopes. So I have a 2 and a -1/2. 2 and -1/2 are negative reciprocals. By the way, a little dash with a VE is the shorthand for negative. So 2 and -1/2 are negative reciprocals. One is positive, one is negative, and 2 can really be written as 2/1. If I flip that upside down, I get 1/2. So because they're negative reciprocals, they are therefore perpendicular. So my lines are perpendicular to each other. By the way, if you're not familiar, these 3 circles in like a little triangle like this means therefore. Okay, so that is the first type of question that you might see. Okay, the second type of question, which is very similar to the first one, is one that involves a shape. So in this example, I said a triangle has points -3, 7, 2, 2, and 5, 5 as its vertices. Is it a right triangle? So essentially, you've got some sort of triangle with these 3 points as the 3 points of the triangle. You have to figure out if it's a right triangle. A right triangle has 2 of its sides, or 2 of the lines that make it, meeting at 90 degrees and therefore perpendicular. So really what you're saying is any of the lines in this triangle perpendicular? So what we're going to do is we're going to come up with the 3 lines that would make up this triangle. So line A, we're going to say happens between points -3, 7 and 2, 2. Line B, we're going to say occurs between 2, 2 and 5, 5. And then line C will occur between 5, 5 and the -3, 7. So all I'm doing is I'm saying if these are the 3 points, and if you think of, I don't really know what this triangle would look like, but you've got 3 points on a triangle. If these 2 points are here and here, there's a line between them. And then if these 2 points are here and here, there's a line between them. And then there would be a line between these 2 points. Okay, so each of these coordinates can be like paired with each other to create a line. So that's all I've done. I've taken these 2, and then these 2, and then these 2 to create my 3 lines. And now all I'm going to do is figure out what the slopes of each of these lines are. So for the first one, let's do 2 minus 7, so y2 minus y1 over 2 take away -3. So 2 minus 7 is -5, and then 2 take away -3 is 5, so -5 divided by 5 is -1. Then for line B, we will do 5 minus 2 over 5 minus 2. 5 minus 2 is 3, 5 minus 2 is 3, that is 1. And then we could stop there, but just for the sake of completion, let's do the last one. So 7 minus 5 and -3 minus 5 is 2, and then -3 minus 5 is -8. So we end up with -1/4 for the last slope. So if I look at this first slope here, -1, if I were to write that over 1, it would look like that. And if I were to take the negative reciprocal of it, I would flip it upside down and make it positive. And then if I simplified that, it would just be 1, because 1 over 1 is 1, which means that these 2 slopes are negative reciprocals, which means they're perpendicular, which means these 2 lines of my triangle, wherever they are meeting at 90 degrees, and we have a right triangle. So this is a right triangle. Okay, So any of the questions that you see in this section that are asking you to identify if lines are parallel or perpendicular, you're always just going to find the slopes of the lines and then compare them to see if any of them are the same or negative reciprocals of one another.